So remember on test 3, you can do the corrections on the test, and you can do the alternative version that I have posted on Blackboard, and you can get additional points for both of those. So make sure you do both if you want to get as much points back for that as you can. Just kind of a scheduling note for us here. We have, after today, we have 12 classes left. Now that last class on the 19th is our graduation day. So I usually try not to put the test on that day, because then by the time it comes in and I get it graded, I am past our grading deadline. I believe is on the 24th for spring semester. So it gets to be pretty tight. So we will have our last test, generally it'll be at the 15th or the 17th, depending on things. 17th most likely is where we're going to have that last test, which puts our next test coming up, the one on the graphing and stuff we're doing now, is either going to be May 3rd or May 5th, depending on how the next couple of weeks goes for us. So just so you guys know, looking ahead, where our schedule is sitting as far as the next test. Won't have a test next week, but the following week, either Wednesday or Friday, will be the test for this unit. Okay, so we left off talking about graphing lines. And we got into things like (2x minus 4y equals 8). And if I wanted to graph that, remember, graphing these, they have to be in the form of y equals. So our next step is to change that into y equals, to solve it for y. So we have to get y here by itself. What did we have to do first to get y by itself there? Subtract the 2x. Very good. So that's gone. We have negative 4y equals 8 minus 2x is 8 minus 2x. What's our next step? We divide by negative 4. Now when we added or subtracted, we only had to do it to one piece on each side. When we divide or multiply, we have to do it to every digit on each side. So here we've got the negative 4y. The negative 4's divide out to give us just y. Here we've got to do it to each piece. So we've got to divide the 8, and we have to divide the negative 2x. So 8 divided by negative 4 is negative 2. Now negative 2x divided by negative 4? Negative divided by negative is a positive. Then we take the coefficient of the x, the 2, and we put it over the 4 to get 2/4, or 1/2 x. So when we go to graph that, where are we going to start? From the origin, we're going to go up or down. The number that is not multiplying x tells us where we start. So that's going to be the negative 2 here. So from the origin, we go down 2. Right there is where we're going to start, at negative 2. The number that multiplies x tells us what to do from there. What are we going to do from that starting point? Recall that number is a slope. It's a rise over run. So the top number tells us how far to rise. So from this point, we rise 1. We go up 1. And the bottom number tells us how far to run. So from there, we run 2, or we go over 2. Another way to think of that slope would be as a rate of change. We went up 1 over 2 just because it's simpler to do that on the graph if you can count out whole blocks on the graph. But you could also think of that 1/2 as being the increase for every step of 1 to the right, or the increase in y for every increase of 1 in x. So x goes over 1. The slope of 1/2 means we go up half a unit. The x goes over 1 again, the y goes up a half. So that's another way of thinking about that 1/2 slope. Gives us the same line on the graph either way. So for the first part of today, I want to focus in on that slope a little bit more. So if we have points on the graph, well, let's say I have the point 2, 1, and the point, let's go 5, 3. And there's a line that goes through those points. Now I'm going to draw the line between the points darker because that's what I'm really focusing in on. But that line can extend past on both ends if it wants to. But anyway, I want to look at finding the slope of that line, knowing that it goes through those 2 points. So I have to, from this point, I'm going to go left to right. From the point on the left, I'm going to rise. Then I'm going to go over, I'm going to run to that point on the right. So I start left, go to right. So if I have it on the graph like this and it's well drawn, I can see from the graph that the rise is 2 and the run is 1, 2, 3. There's 3 spaces. If the graph is a little less detailed or a little bit harder to count, I can find the rise from my coordinate. Which coordinate, the x or the y, describes the rise, the up and down? That'll be the y-coordinate. So this goes from a y-coordinate of 1 to a y-coordinate of 3 to the second point. So you can see from 1 to 3, we rose 2 units. So then, of course, for the run, it's the x-coordinate that describes the run. We went from an x-coordinate of 2 to an x-coordinate of 5. So we ran 3 units. So slope, being rise over run, rose 2, run 3. So it's a slope of 2/3. To find that slope, though, without having to sketch out the graph, there's something called a slope formula. What the slope formula is, and for slope we tend to use the abbreviation M, simply because S is used for so many other things in math, standard deviation, distance, speed, all sorts of displacement, speed, and all sorts of other things. We use M for slope. To find the slope given 2 points, the rise is found by taking y2 minus y1. That's what we did here. We subtracted the y-coordinates, difference in the y-coordinates. And the run is found by taking x2 minus x1, just like we did here, the difference in the x-coordinates. So let's see how we would apply this. If I have the points, let's say I have 1, 7 and 5, 4. To apply the formula, I'm going to label the points point 1 and point 2. So my slope, y2 is going to be which coordinate here? 4. Good. 0.2 y-coordinate is 4. Minus y1 is going to be 7. 0.1, the y-coordinate. For the run, x2 is going to be 5. Good. 0.2, the x-coordinate. Minus x1 will be 1. So we have 4 minus 7 is -3. And 5 minus 1 is 4. Perfect. Thank you. So now we have -3 over 4 or -3/4. It's a negative divided by positive means it's going to be negative, so I can put the negative out front. This becomes way more confusing if there are negative coordinates involved. So we might have 7, -4, -3, 2. So once again, I'm going to label my points 0.1 and 0.2. So in my formula, what's going to go on top here? What's going to go first on top here? 2, perfect. y2, so it's going to be 0.2, the y-coordinate. Minus what? The -4. Good. It's y1, so it's 0.1, the y-coordinate. Now, a lot of people get confused. Well, do we need the minus because when it's a negative? Yes. It is 2 minus a -4. We have to keep both of those in there. What's going to go down here? -3. Good. It's x2, so 0.2, the x-coordinate. Minus, what goes next? 7. Good. x1, so it's 0.1, the x-coordinate. 7. So 2 minus a -4 becomes 2 plus a +4, which makes 6. -7 or -3 minus 7 is -10. Now, once again, it's a positive divided by a negative, so we know that answer is negative. Both 6 and 10 divided by 2 give me 3/5. So it's a -3/5 slope. From that, we can kind of reverse our graphing process. If I have a line on my graph that looks something like this, we can go back and find the equation. Remember, y equals the slope times x plus or minus our y-intercept. I'm going to use the letter B to represent our y-intercept. Looking at this line, probably the easiest thing to pick out is the y-intercept. What's the y-intercept here? -3, perfect. It's where it crosses that y-axis. That's going to be a -3 or -3. The slope is a little tougher to find, but what's the slope going to be here? Well, I can go from here to here. I can draw in that triangle. What's the rise going to be here? Three. And my run? 4. So the slope, a rise of 3 over a run of 4. So that means the equation is y equals slope times x, so 3/4 times x, and then plus the y-intercept. It's a -3, so we just put -3. I might have a line that looks like this. And I'm going to tell you that it goes through a point out here. I'm going to tell you it goes through the point 4,4. And I want to find its equation. So y equals slope times x plus the y-intercept. Looking at this, what's the y-intercept? Six, good. So our y-intercept is 6. Now our slope, we're going to have to use this point, 4,4. Now there's two ways I could do that. I can draw in the triangle here and get that my rise, I actually go down to -2. And my run is 4. So that's a slope of -2 over 4, which can be reduced. Or this point here is the point 0, 6. And I now have 2 points to use to find my slope. So I label this point 1 and point 2. My slope will be y2, which is 4, minus y1 of 6, over x2, which is also 4, minus x1 of 0. 4 minus 6 is -2. 4 minus 0 is 4. So we reduce that would be a negative, both 4 and 2 divided by 2, so a -1/2. So y equals, the slope is a -1/2 x plus 6. If I want to graph a line that goes through a point, let's say it goes through the point 5, 2 and has a slope of 2/3. Well, I can take my graph I'm going to find that point 5, 2. 5, 2 is going to be right in here. And from there, I have a slope of 2/3. So I'm going to rise 2, run 3. So there's my second point. Okay, so you might be thinking, how does all this tie back into medical math? Well, there are a lot of things in math that are rates of change, and slope is simply a rate of change. In medicine, we have flow rates, we have decay rates in the body, of metabolization rates of medications in the body and stuff like that. So we might be looking at an IV bag starts with 1,200 milliliters of fluid and flows at a rate of 300 milliliters per hour. So this is going to give us a graph. We're looking at just the first quadrant here. And most of what we do in medical math is just first quadrant. Both numbers are positive. So this is our time down here in hours. So 0, 1 hour, 2, 3, 4, 5. And then we have our volume up the side here. Now I don't necessarily want to label every notch up the side here. Let's call that 1,000. So what I'm doing here is each notch, each little tick mark is 200 milliliters. And that's going to be labeled my volume in the bag in milliliters. So at time equals 0, in other words, when we start, the volume is at 1,200 milliliters. That's my Y-intercept. The Y-intercept is a starting point, as we had mentioned before. So when time becomes our independent variable, which it very often does, the Y-intercept is an initial point, when time equals 0. The slope from there becomes the flow rate. So the slope is going to be 300 milliliters per hour. Only the volume of that bag is not increasing, it's decreasing. So it's going down by 300 milliliters. It's flowing out of the bag. So it's decreasing by 300 milliliters each hour. So from this point, we go down 300. That's 200. So 300 would be right here. And over 1 hour, right there. We go down 300 again and over an hour. Down 300 again, over an hour. Down 300, over an hour. That should be a line if I'd done my graph straight. So what this graph shows us is the volume of fluid left in that IV bag as a function of time, over time. We can see from the graph, if we did it carefully, that bag should be empty at 4 hours. And at any point along the time of that, we can figure out how much is in the bag. For example, if I want to know at 2.5 hours, how much is in the bag at 2.5 hours? Well, I go up here, here's 2.5, I trace it up to my line, I trace it over to here, and if I did this carefully enough, I would find that that actually comes out to be about 250 milliliters. This actually points out one of the weaknesses in our graphs, especially when we have large scales like this, where each mark here is 200 milliliters. Is it's difficult on a graph to find exact values. And when we talk about graphing as far as statistical graphs, we'll mention that, how the graph is there to make quick reference and a quick visual demonstration, but to find exact values, the graph is not necessarily the strongest thing to use. We might also ask, how long until the bag gets to, let's say, 1,000 milliliters. Well, 1,000 milliliters is right here. We follow that over and down. That happens before the 1 hour mark. Actually happens at 2/3 of an hour. Again, looking at the graph, it's hard to tell, is that 2/3, is it 3/4? Or whatever, getting that exact number would be tough off the graph. So it might be simpler to use the equation. Well, looking at this graph, we can either look at the graph or we can look at our information. we know our equation, y equals the slope times x plus the y-intercept. We know the slope is the rate of change, negative 300 milliliters per 1 hour, or per hour, times x, plus the y-intercept is our initial volume, 1,200 milliliters. Now you might ask, do we need the units in there? We don't necessarily have to, but having those units in there helps us work with them and guarantees we don't make silly mistakes in our calculations. So now going back to this first question, how much is left in the bag at 2.5 hours? Well, we'll use our equation there. X in this case represents the time, so 2.5 will go in for X. And that is 2.5 hours. So we're going to put hours on that. So now mathematically the hours will cancel out. We have negative 300 times 2.5, which is going to give us negative 750. So my original answer was wrong there, by the way. That should have been 450, not 250. This was 200, 400. So anyway, good thing we did double check it with the equation. So that multiplies out to be negative 750 milliliters, because the hours have canceled out. Milliliters are the only units left. Plus 1,200 milliliters. Well, negative 750 plus 1,200, they have the same unit, so we can add them. Negative 750 plus 1,200 is 450 milliliters. So at 2.5 hours, there would be 450 milliliters left. The second question, how long until the bag gets to 1,000 milliliters? Using the same equation, only this time we're putting in the volume, which will be y. So 1,000 milliliters goes in for y equals negative 300 milliliters per hour times x plus 1,200 milliliters. So now we have to solve for x here. So we're going to go ahead and subtract the 1,200 milliliters over here. So that's gone. 1,000 milliliters minus 1,200 milliliters is a negative 200 milliliters. Equals negative 300 milliliters over 1 hour. So to solve this for x now, we have to divide by the negative 300 milliliters per hour. That'll cancel out. To do this division here, let's write it out as fractions. So we've got negative 200 milliliters divided by negative 300 milliliters per hour. So the first thing I'm going to do is I'm going to make the negative 200 milliliters a fraction by putting it over 1. To divide fractions, I have to multiply by the reciprocal. So the negative 200 milliliters over 1 does not change. I'll change this to times 1 hour over negative 300 milliliters. So now the milliliters will cross cancel. Negative 200 times 1 hour is negative 200 hours. 1 times negative 300 is negative 300. And so we have negative 200 hours divided by negative 300. Well, negative divided by negative is a positive. 200 divided by 300 is 2/3 of an hour. So let's do a similar example to that. What we're going to look at here is level of medication in the bloodstream. we're going to say level of medication in the patient. And on bottom here, we're going to label this hours. And over here, we're going to say milligrams per deciliter is the concentration. And we're going to be given this. I'm just going to draw in some little guidelines to help us trace this. Because my drawing isn't necessarily wonderful. So we're given that the concentration is graphed like that. Well, the first thing I ask for this line here, sorry, got tongue-tied there, is to find the slope. Well, I can pick any 2 points on this graph to find the slope. I'm going to pick these two. First of all, is this slope between those points positive or negative? As we move from left to right, it is going up, so it is positive. So we know it's a positive slope. We draw in our rise and run here. This rising from here to here, we can't just count that that's one block on the graph. We have to look at this notch is 150, that notch is 200. So we rise 50, that's going to be milligrams per deciliter. Our run goes from here to here. Well, that is the 2 hour mark and the 4 hour mark, so that is over 2 hours. So we'll write that out as 50, a rise of 50 milligrams per deciliter over 2 hours, which it is okay to leave that as the slope, but we can reduce that to 25 milligrams per deciliter per hour is our slope. It's increasing, so it is positive. The second thing I would ask you for, find the Y-intercept. Well, this one's pretty simple. All we have to do is look up here, and we see that that intercepts or intersects the y-axis at 100. So 100 milligrams per deciliter is our y-intercept. So if we wanted to construct our equation, the equation that describes this, y equals slope times x plus the y-intercept, we put in 25 milligrams per deciliter per hour for the slope times x plus 100 milligrams per deciliter is the y-intercept to get our equation. Four, let's ask, at what time would the concentration reach, what did I start out at, 100? Let's say reach 225 milligrams per deciliter. So we have to look here. Milligrams per deciliter is a concentration. If we look at our variables, the x variable represents time. The y variable represents concentration. So in this problem, we are given the concentration. That's y. And we're asked to find the time. That's x. So we're going to replace y with 225 milligrams per deciliter. And we are looking for x. So to solve for x here, we have to get x by itself. We'll subtract 100 milligrams per deciliter. So 225 minus 100 is 125 milligrams per deciliter. And then to get x by itself, we have to divide by the slope of 25 milligrams per deciliter per hour. Now again, these cancel out here, giving us x. This side's going to be a little trickier to do the math. So let's write that out as fractions. So I have 125 milligrams per deciliter, and I'm going to put that over 1. Divided by 25 milligrams per deciliter per hour. So I'm going to put that over 1 hour. And again, when we divide, the first fraction doesn't change. So that's going to stay 125 milligrams per deciliter over 1. But then we multiply by the reciprocal. So we're going to multiply by 1 hour over 25 milligrams per deciliter. And this is how we can tell we put the numbers in the right place, because the units work out. The milligrams per deciliter cancels out. We have 125 times 1 hour is 125 hours. 1 times 25 is 25. 125 hours divided by 25 is 5 hours. So we're looking for a time, and the units worked out to give us a time. We might also ask, question 5, find the concentration at 3 hours. So I'm going to take my formula here, my equation, y equals 25 milligrams per deciliter per hour times x plus 100 milligrams per deciliter. And again, remember, x is time, concentration is y. So we're looking for the concentration, so we're looking for y here. So the 3 hours goes in for x. Now we make the 3 hours and the 3 hours over 1. The 25 milligrams per deciliter over 1 hour, so that our hours will cross cancel. And what we have then, 25 milligrams per deciliter times 3 is 75 milligrams per deciliter. Plus the 100 milligrams per deciliter. 75 milligrams per deciliter plus 100 milligrams per deciliter is simply 175 milligrams per deciliter. So we can find the equation from the graph, and rather than trying to track these down on the graph, we can use that equation then to find out what would be the concentration at this time, or how long does it take to reach this concentration. Any questions? Okay, we're a few minutes early, but I'm going to go ahead and give you your homework. I believe last time I gave you page 213 through 217 and page 215. Actually, that's not page, this should be 205, not 215. That was a misprint. So if you're having a hard time finding that one, that's why. It should be on page 205. And then the new stuff for today we've covered page 221 to 222, 1 through 15, the odds. That's graphing the lines and using the slopes. And page 226, 1 through 15, the odds. And that is the slopes as a rate of change and our flow rates and stuff like that. So like I said, the purpose behind this, you can see there are medical applications for this. But there's also that push for those of you that are going to, if you wanted to go on to be in a nursing program or something like that, most of the healthcare fields now are requiring that next step of going on to a bachelor's degree. So this would be your college algebra stuff here. Okay, with that, I am going to go ahead and let you guys go. You guys have a great weekend, and we'll see you on Monday.